In this lesson, we're going to talk about particles. And I love particles. You can do so many things. You can do stars, you can do smoke, you can do like rain, snow, dust, fire, everything, anything using particles. And you can have thousands and thousands of them with a reasonable frame rate. And we will test this frame rate. Each particle in WebGL is composed of one plane, which is two triangles, always facing the camera, alright? We will see that shortly. To create particles in Three.js, it's like creating a mesh. You need geometries, you need one geometry. We are going to use buffer geometry, so you can use a cube geometry, sphere geometry, or create your own geometry. We need a material, and this time we are going to use points material, which is a very specific Three.js material. And to create the final particles, instead of creating a mesh like we used to do, we are going to create a points, all right? It's just a Three.js class and that we handles particles. So yeah, about my setup, not much to say. We have a simple cube in the center of the scene, and it's just to test that everything is working. So if everything is working, we are just going to get rid of that cube. And you can just remove it, like this. Okay, cool. Keep your console open as always. So let's create our first particles. You will see that it's not that hard. First, as we said, we need a geometry. So I'm going to put some comments to see where are my particles in the code. And I'm going to do const particles geometry equal new 3 sphere buffer geometry. As always, we have a project that doesn't have a lot of meaning, but if you were creating, I don't know, like snow, you would call it snow geometry or something like that. Then I can use the parameters for a sphere. I'm going to use 1 as the radius, 32 in subdivision, and 32 in subdivision. So it's the width subdivision and the height subdivision, if I'm right. Okay, and that's all. We already have a geometry. Easy. Then the material. So you'll see that it's not that hard either. I'm going to do particles material equal new 3. And as I said earlier, we are going to use the points material, which is over there. And as always, you have great examples. You have code example, and you have a lot of Three.js documentation examples. Click on them, test them, see the code if you need. So yeah, always use the documentation. And I'm going to do new, so 3 points material. It's not basic, standard, stuff like that. It's just point materials, points with an S material. You pass an object as the only parameter, and you can put things inside. And we are going to put 2 parameters right now. We need the size, which is going to be the size of the particles. Let's put 0.202 like in the example. And size attenuation. And the size attenuation, we create perspective, meaning that if a particle is far from the camera, the particle will be small, and if it's close from the camera, the particle will be big. Okay, cool. Oh yeah, by the way, you can change those properties after the instantiation. So I can do an empty instantiation like this, and then change particles material, just like the other particle, the other materials, and do size equal 0.02 and size attenuation equal true, just like that, all right? You will get the same result. If I save, no error, let's continue. Finally, we can create the points. So I'm going to add some comments just because we are going to add a lot of code after that. I'm going to do material, and then I'm going to do points, like that. So I can create the, oh no, sorry, it's particles. So yeah, let's say points, it's fine. Const particles, so it's the final particles. And we are going to do new 3. And this time it's not mesh, as I said, it's points, like that. And you give the same parameter as for the mesh, which is the geometry. And the second parameter is going to be the material. And don't forget to add it to the scene add particles, and we get the particles And that's all. End of the lesson. Bye. I'm kidding, we have so much more to see. So you can move, rotate. As you can see, if I get close to the particle is big, and the particle behind in the depth are small. All right, it's because of the perspective, and we can change this with the size attenuation. You see that we get those particles, and if I move, oh sorry, no, we have to put false, not just comment it. So false, and as you can see, we have small dot regardless of the distance. All right, if I just increase them a little so we can see them a little more. Actually, some of you might not see anything right now. We are going to talk about this later. Put a bigger number, like 4, and as you can see, it's 4 pixels, regardless of the distance of the particle, which can be interesting. It's actually a little better for performances, but in our case, we want realistic particles. So we are going to use 0.02 and activate the size attenuation. Like if we are creating snowflakes, if a snowflake go very close to the camera, we want to see a big snowflake. Okay, cool. So that's it for simple particles. What if we want to create our own geometry? And we can do that, obviously. And it's going to be the same code as we did in the previous lessons where we created our own buffer geometry. What you can do to practice is a very hard exercise, is to just try to create random points, a buffer geometry, an empty buffer geometry, and then add random points everywhere. Try to do it, pause the video, and once you've done it, or maybe you failed, go back to the video. It's very hard, all right? It's okay. If you fail, it's okay, but the good thing is that you practice. It's important to practice. I will go to the next slide and do it with you. I have always trouble doing it. Even after doing it like 100 times, I still do mistakes. So it's okay. First, I'm going to choose a number. I'm going to choose 500. Yeah, 500 in the example. Let's do the same. So we get 500 particles. Oh, by the way, we don't need to use the sphere buffer geometry. We are going to use the buffer geometry. So it's empty right now. You can test it like that and you get nothing. All right, but no error. So I want to create 500 geometry. I can't wait to crank this number up, but it's for later. Let's first make things work. If you remember, to add positions, to add vertices to a buffer geometry, you need to add an attribute, and it's going to be the position attribute. So we need to fill this position attribute, and we are going to use special arrays. We are going to do positions equal new float 32 array. All right, this is a JavaScript float 32 array. For now, this part has nothing to do with 3GS, and you have to specify how much element in the array, and we are going to use count multiplied by 3. And I'm going to do some drawings to explain. We are going to create a one-dimension array that will look like this, and we are going to put a lot of values. Remember that it's the position array, all right? It's this position array, it's float 32 array. And we are going to put values 3 by 3. So it's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. Come on, a little more. Okay, that's enough. And because it's a one-dimension array, we are going to put the x, y, and z of the first vertex, and then the x, y, so it's an x, y, and z of the second vertex, and then the x, y, and z of the third vertex. And they will be separated like 3 by 3. And we need to send this array to the GPU. This is just optimized. It's to have good performances. We can send a lot of data with those types of array, and the WebGL can handle those data much faster than if it was like an array of objects or stuff like that, which is why we have to do that. So we were talking about the length of the array. Well, if we have 500 vertices, well, we need 500 times 3 because there is 1, 2, 3 values for each vertex. All right, so this is count multiplied by 3. Okay, cool. Then we need to fill this array. And because we just want points everywhere, we are going to do so, just fill this array with random values. So to do that, we are going to do let I equal 0, I inferior to count multiply by 3, because I just want to fill the array. And we have this amount of element in it, so we are going to use the same. I plus plus, and then we just fill the array at the I position. So it's going to be position I equal math random. And I will just do that. I won't follow the example right now. We will improve this later once it's working. So then we have our float32 array. What we need to do is create a buffer attribute. To do that, we need to do const. Oh yeah, we can do it right away. You know what? Let's do it right away to gain some time. We're going to do particles geometry, set attribute to add an attribute to the buffer geometry. We need to choose a name. So I will put it with the line breaks, but you can put everything on the same line if you want. So it's going to be position. And then we pass not directly the float32 array. We have to create a buffer attribute. So it's going to be new 3 buffer attribute. And the parameters of the buffer attribute are the array. So it's going to be positions, with an S, and then 3. Why 3? Why 3 is because we need to say that we need 1, 2, 3 value for one vertex. Then 1, 2, 3 value for the second, 1, 2, 3 value for the third. If you don't provide this, the GPU will try to use, I don't know, maybe by default 1 value, and we try to position a vertex with only 1 value. It's impossible. So you have to say 3. Okay, cool. I think it's pretty nice like that. And it's working. You can refresh and you should have your particles. Let's improve the positions, because right now they are starting at the center of the scene and they are spreading in the X positive, the Y positive, and the Z positive. But I want particles everywhere, and I want to feel like I'm in the middle of the particles. So yeah, let's go. We just need to play with this position, and as I already did multiple times, I'm going to do minus 0.5 and multiply the result of that by a big value, like 10. As you can see, we have particles everywhere, which is working fine. If you want me to explain this again, I can. Let's use those drawings. If I have a value, let's say from 0, and this is 1, right? We get something like that. Oh no, it's a bad idea, wait. We are going to do like 1 here. I want particles like everywhere, so it can go from, I don't know, minus 5 to positive 5. If I do a math random, I will get a value that goes from here to here. All right. So this is just, let's say, random. Yeah, I will write random. If I do minus 5, I will get a value that goes from, I will put the minus 1 here. So this is minus 1. If I do minus 5 on this, I will get a value that goes from here to here. So it's random value minus 0.5. Okay, so I get a value that goes from here to here. So it can be as positive as negative. And then I can multiply this value, I don't know, by 2, 3, 4, let's say by 2. Then I will have something that goes from here to here. So, you know, it's not by 2. Let's say by 4. All right. So I will get multiply by 4. And it will go 1, 2. So it's going to be 2 like this. And minus 2 like that. All right. We start with a random value that goes from 0 to 1. We do minus 0.5. So it goes from minus 0.5 to positive 0.5. And we multiply it by 4. So it goes from minus 2 to positive 2. Okay, let's get back to our code. So we have our particles. It looks like stars, snow, well, it can be whatever you want. But anyway, we have our particles, which is great. Let's try with more particles. add a 0 to the count. For me, it's working. Add a 0 to the count. Still working. We have a lot of particles, a lot of snowflakes. Come on, even more. 500 particles. It's still working. We can't see much, but it's still working. I don't know, maybe 5 billion. Billion, is it billion? We say million in French. So even more. So we can't see anything, but it's still working at a decent frame rate. I think the frame rate is perfect right now. Okay, maybe don't put too much particles. You might crash your computer. But as you can see, we can add a lot of particles. Okay, cool. So we are going to keep 5,000, and we can also increase the size, and the size is over there. We are going to use 0.1. You can do differently, but if you want to test as I'm testing, put those values. So it's 5,000 and 0.1 in the size, and we keep the size attenuation. Okay, cool. Let's dive deeper. We're going to test the color, the map, and the alpha map. So yeah, we can change the color of the particles with the color property, and it works just like any material. I can put it in here. So I can do, I don't know, color red. Now we get red particles, which is great. Or I can do it after instantiation. So I can do particles, material, color, and I cannot do just red. Remember that the color is, after instantiation, the color is a color class from the 3GS documentation. So if you look there for color, it's that. So we need to instantiate this class. We are going to do new 3 color and put any value like red. It's the same result. If you want to use my value, I think it's some kind of pink. Yeah, that's pink. Cool. So it's FF88CC, and we can move forward. So we can just change the color, which is great. What we can do is also use textures. I put some textures in the static folder, textures, as always, particles, and here are some particles. All right. We are going to test one. I don't know, maybe the star. Yeah, why not this star? It's not the same as the example, but anyway, as the lesson below, the text version. But anyway, we already have our texture loader, and because we want to use this image in the 3GS in our scene, we need to load a texture. So let's go. Const particle texture equal texture loader load, like this, and we put the path as always starting from inside the static folder, textures, particles, and use whatever particles you like, and you can change it after. So you can use this cute heart. I think I will go for the star. I don't know if it's a bad idea. Anyway, maybe I will change it once I can see that it's a bad idea. And now that it's loaded, let me check, no error, so it's probably loaded well. We can get back to the material and change the map. So it's just like any material. So it's particles material dot map equal, and you just put your particle texture here. And we get something like that, which is great, but we cannot see much. So I think I will go for the one in the example, which is the number 2, but you can test any of those. It's fine. Yeah, this one is bigger, more visible. So I will go for the 2.png, but you can use any one you like. All right, about those particles, small word, they are from this guy. So you have the links as always in the bottom panel. So this guy is doing a lot of great assets. Follow him on Twitter if you want to see those assets. And he put those particles right here. I also put the link, so there is even more particles if you want to use them. Just check his website. He has a lot of things. You can use those particles. It's a CC0 license, so you can do anything you want with it. So check these guys and his assets. A lot of great assets. 3D assets, many things like that. Unity assets also, I think. But you can also create your own, and it's as simple as opening GIMP and just drawing circles, stuff like that, and use those particles. You can create a PNG, a JPEG file, load them, and just use them. If you want, you just pause the video, create your own particle, and follow the exercise, and and send it to me on Twitter. I will be glad to see your particles. You can create snowflakes. If you look closely, you will see that the front particles are hiding the back particles. Yeah, let's try to have this bug. We are going to focus. It's going to be, yeah, this one is great. Look at this one and look at the edges of this one. As you can see, it seems to be hiding other particles. If you can't see in the video, test on your experience, on your version, and watch the edges, and you can see like if it's hiding something behind, which is not very realistic. What we want is that the dark part is transparent and the rest is visible. We need to fix that. Be careful, we are diving in something pretty hard. So first, instead of using the map, where is my map? Right here. We are going to use the alpha map, right? That's a good start. So instead of the map, we use the alpha map. And right now, it's not working. What did I forget? Did I forget, sorry? Yeah, forget the transparent. As always, transparent equal true. Let's test it. All right, now it's better. It's better, but it's not perfect. Let me see what's here. Yeah, you can still see edges of particles. So let's try to find one. Okay, I found one. Can I get closer? No, it was hard. Yeah, maybe this one. Look at those two and look at the edges. Sometimes it works, but sometimes you can still see the edges. All right, try with some of your particles. It's like a bug because these particles right in front of me is hiding the particles behind. Like the square is hiding the particles behind, but it should not. See, there are problems right here. Well, that is because the particles are drawn in the same order as they are created. All right, the GPU just draw the particles, and maybe one particle got drawn in front of the other. Maybe it was the opposite, but anyway, it got hidden because the WebGL, if it's alpha 0, I mean, for the same object, it's a little harder, but this is what's happening right here because we only have particles. It will draw above the rest, and if the alpha is 0, well, the GPU will just think that the alpha has to be 0. So we have a problem. Currently, the GPU is not doing things right because it just draws, and if it sees alpha 0, it doesn't draw anything, and maybe the one behind is getting drawn after, but there is already something drawn, so it doesn't draw. Well, it's a mess, and we need to fix that. And it's not going to be easy because there is multiple ways of fixing that, and there is not just one way. It really depends on your project. So we have to dive in this. First, we can use the alpha test. This is a good fix. Not perfect, but a simple and good fix. The alpha test is a value between 0 and 1 that enables the GPU to know when not to render the pixel according to the pixel transparency. So, if the GPU is rendering this particle, it will see that this is black, and it will not, currently, it will just render it as alpha 0, but it will render this pixel. Even if it's alpha 0, the GPU will render it as being invisible. What we want to do with the alpha test is tell the GPU, don't even render this part, all right? Don't do anything. Like if there is nothing here, just ignore this part. This way, the GPU will not draw anything here. It will not try to draw an invisible pixel that will, at the end, get this bug we have. The problem is that sometimes it's barely visible, like here. So we have pixels, so should we render or not? Well, it depends on the alpha test. Test it, you will see that it's going to work. What we can do is alpha test equal, and I'm going to use the same value as the example, which is 0.001. And as you can see, it's better. See? You get a better result. But if you look closely, okay, I have one here. See there? So it seems to be working, like the corners are not rendered, so I can put it like this. And this particle doesn't hide completely the particle behind. I know it's small, sorry, but it's hard to position the camera perfectly. So it's kind of working, but the edge of the circle is still hiding the one behind. So it's a pretty good fix, because if the particles are moving like that permanently, you won't be able to see it. But if the user can just stop and watch at one particle like this, and he will see that, oh, this is strange, we can see the edge. So it's up to you, but the alpha test is a pretty good fix depending on what is your project exactly. So the next solution is about depth test. When the WebGL is drawing those particles, let's say it's drawing this particle, the WebGL will first test if this particle is in front of the other particles or not. If it's behind, the particles won't be drawn. If it's in front, the particle will be drawn. And this can create a mess with what is really in front or behind. We can just play with it and do deactivate the test. So the WebGL will just draw everything regardless of it's in front or not. By deactivating, so it's the depth testing. First, we can deactivate the alpha test. Keep it in your comments so you have it somewhere. So we deactivate it to focus on the depth test, and we are going to do particles material, depth test, false. So the GPU will just draw and not try to guess if it's in front or not of the other. Does it fix the problem? Well, it looks like so. See those two là? Yeah, it seems to be perfectly fixed. With this one, yeah, it looks fixed. Maybe we can just keep this one. Unfortunately, no. Deactivating the depth testing might create bugs if you have other objects in your scene or particles with different color. Let me show you, we'll understand. I will add a cube, a simple cube. I can add it after. So it's just a box, a mesh basic material. We add it to the scene. There is nothing special here. We just add this cube and see what's happening. Look at the particles that are supposed to be behind. So it's a cool effect. We have like another dimension, something like that. But it's not realistic. We should not be able to see the particles behind the cube. It's impossible. And still we can see them. So yeah, look at this one right here. I move and I can still see these particles, which is wrong. And it's because we say to the WebGL to draw particles and just don't care about what's in front or not. Draw the particles. Well, the WebGL will draw particles even if there is a huge cube in front of you. So yeah, that's a solution, but if you have other things on your scene, it won't work. And if you have different colors on the particles, it won't work too, because maybe the particle behind will be drawn in front of the other, and you will see it because they have different colors. Currently, we cannot see it because they are all pink. Right now, it's pink, we don't see different, but maybe the one here, the small one, is being drawn in front of this big one, which will be a mess. So it might work depending if you have just one color and just particles in your scene, it might work. All right, the next solution is using the depth right. It's kind of the same idea, but the depth of what's being drawn is stored in what we call a depth buffer. We say in the depth test that the WebGL tests if what's being drawn is in front of what has already been drawn. But where does the WebGL save what has already been drawn? Well, it's called the depth buffer. It's like a grayscale texture of what is being drawn, and the WebGL, when drawing your objects, your particles, stuff like that, will also draw in this depth buffer, just to be able to remember that, all right, there is something at this distance, there is something at this distance, and when drawing something else, the WebGL will check on this depth buffer, is it in front or not? Because he will have this information. We won't dive too deep into this depth buffer thing. What we are going to do is tell the WebGL not to draw inside that depth buffer. So we're not telling the WebGL to not test this depth buffer. We are telling to not draw the particles inside that depth buffer. So I will comment the depth test, and I will deactivate the depth right. So we are not writing in the depth buffer. And as you can see, it's working. Great. And it seems like a pretty good result. We don't have troubles with the cube. The particles are well drawn. As you can see, we have those. No problems at all. And actually, it's a good solution. It might, you might have bugs in very specific situation, but for me, deactivating the depth right was many times the right solution. But it's up to you. You really have to test. I gave you few techniques to fix this drawing particles problem. You will have to adapt depending on your project. All right. So keep those somewhere. Maybe create a snippet or something like that, and use them. Try different values. You can even combine them for a better result. Those have not a lot of performances impact. All right. You can just tweak them without thinking of performances. Okay, cool. And there is a fourth one. And the fourth one, it's not really part of those three solutions because it will have first a different result on what you get at the end. And also it can have a performances impact. All right. So this one is a little on the side, but I have to show it to you because it's really cool. So it's the blending, and maybe you have heard of blending in other domains like, I don't know, Photoshop, stuff like that. And it's the same kind of. First, we are going to keep the depth right. Yeah, let's keep the depth right false. And we are going to add a property, change a property, which is blending. And we are going to use 3 additive blending. And you will see the result, and we will talk about this result. 3 additive blending. And we can see this result. So I can't see it, but I can see much of it. Try to guess what is really the difference. What you can do is add a lot more of particle. I will add way more particles. And as you can see, when we have multiple particles like in the same pixel, because they are rendered one on top of each other, it gets like really bright. It's the additive blending. It's because instead of just drawing a pixel on top of the other, and also it's another color, okay, I just ignore the one before, and then it's blue, and then it's yellow. This time the color will be added to what already exists. So the WebGL will draw this one, and we'll add the color of this one to the one before, and we'll add the color of this one to the one before, and we get something that looks illuminated, like it glows. We get white. If you combine red, green, blue, a lot, you get something really white. It's like combining not paint, it's more like combining lights. If you put a red light, a blue light, and a green light, you will get white, which is great. We can have a really cool result, like sparkles, stuff like that. You better use the additive blending. Be careful, the additive blending can impact the performances, all right? You can have troubles with that. If you have too many particles and it's huge particles and then you activate the additive blending, maybe we have a frame rate drop and we have to find solutions. Okay, cool. Let's not use that much particles. We can use 20,000 and we can remove the cube. So our test cube like that. Okay, cool. Hang on. Yeah, as I said earlier, we can have different colors for each particle. And it's not that hard. It's hard, but we know the techniques we are going to see here, so it's okay. The idea is that because we need to provide, we want different color for each particle. Because we are going to provide a value for each particle, we are talking about attributes. Just like we have a different position for each particle, we will have a different color for each particle. So let's go. Let's add a new attribute. And it's going to be over there. Because we already added the positions attribute, we are going to do the same. And we are going to create colors. And it's going to be a float 32 array because the color is composed of RGB. So it's exactly the same. And I will do a drawing just to explain as again. So this is my color attribute. And now we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, as always. And I will have R, G, B, R, G, B, R, G, and B. And it will go 3 by 3. So it's exactly the same as the position. One vertex, so 1, 2, 3, then second vertex, then second vertex. And that's all. So we are doing exactly the same kind of thing. So let's go. Try to do it on your own. Don't watch the video and the slide at the bottom if you want, or just follow me. So I will create a colors, and instead of doing another loop on the another loop to fill the positions, I will just use the same loop, and I will fill these colors by doing colors, and it's even simpler. I equal, and we are going to just create a random colors. And a random colors, it goes for R, G, and B. For each one, it goes from 0 to 1. So I will do math random, and that's all. This way I get random values, and I can do a drawing to explain that. So the R will be, I don't know, something like this. This one will be something like that. This one will be something like that. So it's just from 0. Imagine like that 0, and this is 1. This one we do 1, this one we do 2, 2, 2, etc. So it's just a random value that goes from 0 to 1. So yeah, let's go. Random values, I can just save. All right, it's working. And then I can add it to the geometry attribute. So I will do that. And you have to call it color, singular. Okay, that's the name that will be used inside the material, inside the shaders of the material. And then we can use the colors array to create a buffer attribute and send this buffer attribute to the geometry attribute. And we get the same result. It's okay. We just need to notify the material that it should now use vertex colors. To do that, we simply add vertex colors with an S, so it's plural, true. And yay, we have every colors. Yay, it's looking great. One interesting thing is that the base color is impacting those color. All right, it's kind of mixing your base color with the vertex color. So if you just want to see your colors, you can comment this part. And we will get something like this, which is cool, really cool. Okay, great. It doesn't look like anything, we're just testing stuff, but you can do a lot with that. All right, let's animate. This part is interesting. And we will do some trigonometry again. So there is multiple way of animating particles. Because these points, let me show you the points, inherit from object 3D, we can just animate it like any object. All right. So points, this class we use to create the particles, inherits from object 3D. We can play with its position, rotation, and scale. So we can animate the whole particles, and we are going to start with that. Go to the tick function. Let's add update particles. As always, before doing the render, it won't change a lot, but still, let's do it properly. And we can play with our particles, and let's do a simple rotation like Y equal, and you can use the elapsed time as always, and you can just do that and see the result. I'm not touching anything, and it's rotating. It's going way too fast, sorry. Let's try not to be dizzy. And as you can see, they are all rotating. And if I put my camera on top, you can see that the whole thing is rotating. It's really simple animation, I know, but still, you can do that. So you can move the whole particles. If you want, I don't know, to do a snow, maybe you can just do something like position equal minus elapsed time multiplied by this, and they will fall like this, all right? But at a point, you won't see any particles, but still it's working, all right? So if you don't know better solution, you can do that. All right, I will get back to the rotation. Comment it, because we are done with this one. We need more controls, so we need to be able to animate each particle. All All right, animating the whole thing is cool, but I want to have control over each particle. How can we do that? So first we command the particles rotation to be able just to see what we are going to do right now. And what we can do, remember that the particles' positions are saved inside an attribute. And we can access this attribute, don't do it, I just want to show it to you, by doing particle geometry, attributes. Look at this, we got the position and the color. And we can access, so we can change the color, but it's not really interesting. I can access to the position. It's a buffer attribute, I know that because we created that buffer attribute, and we can access to the values in the array, like this. And we have a huge array with a lot of values. It's this array, all right? It's a one-dimension array with all the positions. We can change this attribute. Be careful, I know that some people might be like, no, don't do it. I know it's a bad idea, but I will explain to you why later. Still, you can do it. So yeah, let's go. Be careful though, this array is a one-dimension array, so if we want to update one particle, we will have to do the first 3 values and then go 3 by 3, all right? And we're going to do a very specific animation, and we need to understand that. So we can access those. What we are going to do first is loop on this array, all right? We will do 4, and because we have the number of particles somewhere, I think it was just count. Yeah, see, we have the count, I should have called it particles count or something like that. Anyway, we have this count variable. We can loop by doing let I equal 0, I inferior to count, I plus plus. All right. I put the console inside, but don't use it. Do not save. Right now, we are not doing anything. So right now, we are doing 0, 1, 2, 3, 4, 5 until we get to the number we said earlier, which is 20,000. Okay. The problem is that we have more in our array because we need 3 values for one vertex. So our array is way bigger. There are multiple ways of doing this. We could do something like multiply by 3, but I want to show you another solution, is to have another index, and we are going to call it const I3, and this one will be I, but 3 by 3. And to do that, we just multiply I by 3. So we have one doing just 1, 2, 3, 4, 5, 6, and we multiply it to get our I3 that we do 0, 3, 6, 9, 12, etc. So we can use this one. It's just another way of doing things, all right? You feel free to do whatever you want. It's not that important. What I want to do right now is let's keep things simple. We will move the particles with a sinus, all right? We will move the particles so that they do just that, okay? But how do we access to the y of each particle? So we have the I3. So this is the I3. I'm going to use, this one. We have the I3 that will be equal to, so it's I3 that will be equal to that. It's hard to say I3, I3, I3. So if I want to access the y property, it's going to be I3 plus 1, and I will get this one, I3 plus 1, and I will get this one, I3 plus 1, and I will get this one, all right? If I want to access to the x, it's just I3 plus 0, where it's just I3. And if I want to access the z, it's I3 plus 2, I3 plus 2. Okay. So I want to play with the animation we want to do is just wave. We want the particles to wave like this. So it's going to be particles geometry, attributes, with an S, the position, be careful, it's singular, array, and I will access to the key at I3 plus 1, all right? Because I3 gives the x, we want the y, so it's I3 plus 1. This is the y value, and what I can do is just math scene and use the elapsed time. All right, I just want to see a result. It's a lot in a row, it's a lot at once. I just want to see the particles moving, okay? So I think it's fine like this. We save, and unfortunately, something happened. All the particles got flat, but it's not animating. Maybe the value isn't high enough. Well, math sign goes from -0 to +0. So we are supposed to see like at least a movement like that. It's not working. Well, it's normal. We need to tell 3GS that this attribute has been updated, that the attribute has changed. And to do that, once you are done changing this attribute, you can do your attribute, so it's position, needs with an S, update. Like this. You just tell 3GS, by the way, this one needs update. And 3GS, before rendering, will do the update. All right? And if you test like this, all right, it's moving. Great. You have to notify 3GS that this attribute did update. Cool, but it doesn't look like wave. At least the animation seems to be waves, but I want to really see those kind of waves. All right? Well, to do that, we're going to offset this scene animation like that, depending on the X. All right, we're going to use the X position of those particles to offset the animation. So the one on the far left will do that, and the one a little on the right of the first particles, we do the same animation but slightly offset, and then we'll get something like that. All right, we just need to offset the math sign. So first, how can we get the X? Well, you know that. It's the same thing. So I will do const X. See, it's the X position. It's I3 plus 0 because it's this one right here. It's I3 plus 0, I3 plus 0. And as we said, plus 0 doesn't mean anything. You can just do nothing here. I usually just let it plus 0 because I like to always do plus something. So I know it's the X, I know it's the Y. It's not something that I forgot, but let's remove it because it's completely useless. So this is the X value, okay, of each vertex. So before updating the Y of each vertex, we get the X of the same vertex. And we can use this X inside the elapsed time just by offsetting this elapsed time. And see the result? Nice. It's working. We have waves, particle waves, which is looking great. The frame rate is okay, but I can tell something is that right now my computer is the fans are working hard. Why? Well, because this is a bad idea. You should not do that. Right now we are updating thousands and thousands of particles, and it's wrong. And it's a lot of work for 3GS, for the GPU, for everyone, even for us. So this is a bad idea. If you don't know better, yeah, why not? But we will learn a better solution. And if you don't have much particles, like, I don't know, 100 particles, because it's just sparkles doing something in the back, well, maybe you can do it, all right? If you don't have frame rate issues and your experience still work on mobiles and old computers, well, just do it. I already did that because I didn't have much particles. It was like 50 particles. It's okay. I'm just updating a very small array. Let's do it. But how should we do it? Well, it's by using a custom shader. Instead of using instead of using the points material of 3GS, which is great, it's a very cool materials, and we can do a lot with it. But if you want to do this kind of animation the right way, you will have to create your own material in order to create your own shader. And shader, it's a hard part, but you will learn shader with me in future lesson. All right, it's much later in the course. Yeah, well, we are done for now. See you in the next lesson.